Hi, this is Zena Harris.
And I'm Mark Rabin.
Welcome to the tie-in.
Welcome back, everybody. On this episode, this is part 2 of the Showpower behind the scenes interview at the Global Citizen concert in New York in late September. And on this part 2, I interview Tim Benson, and he takes me behind the scenes into the ins and outs of the Showpower concert battery system that's owned by Coldplay, and really gets into the nitty gritty. So for all you techie energy nerds out there that are looking at what it's like to power big concert stages and big music acts, this is one that cannot be missed. Our part 1, which you can find us in our other list of podcasts, is with Paul Schurink, who's the founder and co-founder and CEO of Showpower. And he gives us a really beautiful overview. And we also have our other interview, the formal podcast with Paul Schurink as well. Showpower is really impressive, and they're looking to grow quickly, and they're proving that some of the largest, most important stages in the world can be powered with renewable energy and battery systems. I hope you enjoy this, and yeah, we'll catch you soon.
Hello, everybody. I'm here today with
Tim Benson, the tech director at Showpower Global BV.
Amazing. And right now, Showpower is at the Great Lawn at Central Park to power the Global Citizen concert with large batteries. And this is Showpower's first foray into the North American market with these particular batteries.
Correct, yeah. We worked on Lollapalooza earlier this year, but we used batteries from Atlas Copco.
Right, Atlas Copco hybridized with diesel generators.
Yeah, through CES.
Yeah, and those were their shipping container, like their 10 by 10 size,
correct.
250 kilowatts.
I believe 250 kVA, 500 kilowatt hours.
Yeah.
So it's like a C2 battery.
Yeah. Amazing. And that was successful.
It was very successful, yeah. It was successful for two reasons. It was successful because Paul, our illustrious leader, did some amazing load planning, so he understood what he was up against in terms of power and more particularly energy, and it was successful because CES supported us, very, very effectively.
Right, and we're talking about stages that require megawatt hours of storage of energy to run the full entire production.
Correct. Yeah. There were multiple batteries working essentially in island mode, coming off the generators. But yeah, collectively, that's megawatt hours worth of energy.
Yeah. And so, what do we have here right now behind us? Maybe.
Okay. We have a beast.
So here, just so I can show everybody here, we have battery inverter setups, modular setups that look like we have 1, 2, 3, 4, 5 by 5, so almost 10 setups?
Yeah, so we have 5 inverter units, and each inverter unit pairs with 2 battery units. So effectively, you have a singular system of 250 kVA output with 400 plus kilowatt hours across that unit. But the unique thing about the Showpower unit is its configuration. So currently, we're operating it in island mode.
Yeah.
So effectively, we're using 5 250 kVA BESs to power the stage services. Typically, we run the system in what's called a ring. And that means all of the units interconnect and share the load through their inverters.
So you have a power sharing feature. Is that an inverter feature that's already existed, or that's something that you guys had to engineer and program?
It was engineered and programmed using Norica's very skilled coding that they use on their battery balancing sites.
Yeah.
But the beauty is that it's kind of bi-directional, so we can send, for instance, we're standing in front of Phil here.
Yeah.
Phil, I'll explain why they've got the names they have shortly. Phil can basically send power to Angus on his left, or he could send power to Brian on his right. if Phil is getting close to his output capacity, he can call on Angus or Brian or Stevie or Cliff's inverters to supplement him. And the other amazing thing about the mesh is if you lose an inverter or you lose batteries associated with an inverter, the rest of the units take up the slack. So you don't lose the power going to that stage service that particular inverter is out.
So there's an instant transfer?
It's just constant bidirectional.
Okay.
So there's not even a transfer relay. It's basically just the energy and the power is moving around the mesh the whole time. So
wow.
It's pretty clever stuff.
So I'm assuming though there's an auto gen transfer switch. Then if something were to happen, your fail-proof islanding system that sort of is going, something catastrophic happens,
yeah,
which can happen, but I'm sure it hasn't happened because it seems like you've got a lot of redundancy here. But then it goes to that generator unit behind there.
Yeah. So what makes our system unique, say compared to other three-phase battery systems, is the fact that we have multiple levels of redundancy.
Yeah.
So for instance, I've run a show using these units where for various reasons we've lost 2 inverters. So we've gone down a theoretical capacity of 500 kilowatts and I've lost 5 batteries. So we've gone down, quite a lot on the energy storage capacity. The rest of the units then pick up the slack. Yeah. If something endlessly catastrophic happens, we have the ability to basically resync to the generators, switch off the inverters, the breakers stay closed, and there's an instant transfer, which is less than milliseconds from generator to load.
Right. Is the generator typically running when it's so? Just as backup, you're running the generator during the show, just in case.
Generally not. No.
Okay.
One of the reasons for that is, apart from obviously the sustainability and the emissions reductions, is the quality of the power when we're running in an island mode is considerably greater than when we're synced to a generator. Our inverters connect to the generator, so they match the generator's voltage and frequency. Yeah. Now we know generators are electromechanical systems. You have to apply power factor to them because they don't generate everything that they can potentially produce. An inverter is completely different. There's no electromechanical systems in there. If it says it outputs 250 kVA, it outputs.
It's pure sine. It's
precisely.
Fans love it. People love it.
So we get no voltage drop down at the stage, and the power quality. If, for instance, audio have got power analyzers on their setup around their transformers, they prefer island mode. It's a better quality of power. It's less noise on their system in Pro Tools, that kind of thing. Yeah. When we're connected to the generator, you may see a marginal 0.5 to 1 volt drop down, but that's because we're following the generator's voltage and frequency, and it's not as stable as a pure sine wave supply.
Does the generator charge the batteries at the same time, and then there's a pass through to go to the
It can
inverters?
do, yeah. If the generator is connected to the inverters, the incoming supply will target the load first.
Yes.
And then everything else is sent through to the batteries.
Brilliant. And that's again by your spec, or that was just happened to be a byproduct of the components and technology that you're using?
That's a requirement of ours. So obviously we've got about 100 years experience in events. What makes us as a team quite unique, apart from the fact that we're all nerds, is the fact that we study the inherent characteristics of electrical fixtures. We don't look at a stage and say, there's 25 power 54s up there.
You know megawatt of power. No.
Yeah, we know.
You know exactly.
We know how those powers work.
Yes.
And therefore we can factor in things like simultaneity, diversity, etc. And we can come up with a much more realistic estimate of the energy required for that load. For us, power is less important. Yeah. Energy is the most important metric. And as you know, energy is power times duty cycle. So how long you're operating it for. So we've been doing this for a long, long time. We can look at fixtures. We use our MyZap app to actually calculate that and spit out a report.
So right now, how do you know what the draw is on this today? Right now, or this moment? Because I can hear the music right now. So are they sound checking right now with powered off the batteries?
They are indeed, at the moment.
Or these are power. You refer to this as power systems. How do you refer to these units?
We call it a smart grid system. These are the battery modules.
Yeah.
And the inverters we call the head unit.
And this whole unit is batteries. This whole unit is inverter. Yeah. This whole unit's batteries. And it goes on the same.
Yeah. So there's a pair of batteries to each head unit.
And you said these are 400 kilowatt hours?
Collectively, I think it's about 440 across the 2 batteries.
Okay.
The 2 modules. So.
Right. And you've got cooling.
We've got liquid cooling into here.
Cooling. Yep.
So basically, air passes through the lower vent, gets sucked up by the fan in there, which operates off a pressure switch. The compressor then kicks in, sends the coolant through the batteries, up and down the chain like that, and then spits the hot air out.
And was that already designed into the battery pack, or that's something that, again, you guys...
That's something that we engineered. Yeah, basically. We obviously have liquid cooling in here. We have HVAC cooling in here. But as we were discussing earlier, version 2 will probably have liquid
It's critical that it does.
well. Yeah.
Have you ever had any issues with the liquid cooling?
I have. It's less about the liquid cooling and more about the transit. These batteries have been around the world about 10 times in the last 3 years. Some of the European roads and the South American roads are not as good as we'd like them to be. There's nothing we can do about that. They're sitting on a truck, they're traveling for 12 hours, they bounce. We've had problems with
so you've had to harden the have you end up putting dampeners and so on inside?
We've retrofitted some of the cooling. But I have to say, the cooling was only really affected after 3 years of travel. So that's pretty reliable.
Yeah, so not a lot of way less maintenance, but there still is a maintenance component to any type of system.
100%. It needs servicing regularly. It's just, in that sense, it's just like a generator. You do a 500-hour filter change, oil change, etc. With the batteries, obviously there's no oil, there's no filters, etc. But we do constant servicing on them.
I mean, I'm assuming you do have filters for some of these things if you were going in a really dusty place.
Well, the filters that are inside there are on either side of the inverter. They're actually sine wave filters. We do have smaller vents on the other side of the unit with 24-volt DC fans.
Yeah, this is the output.
Yeah.
This is your HVAC cooling system.
That's the HVAC for the inverters. And that's thermostatically controlled.
Right, so here we have the whole power setup. So you have the diesel Jenny in the sort of a 30-foot, 40-foot. Then you have your 10, call them again, power systems?
We have the five smart grids.
Smart grids, 5 smart grids. Tell me, how different is it today than when you started 25 years ago? You mentioned you were obviously probably one of the first pioneers in the space to do live event production with batteries.
100%, yeah.
What do you say is the main key differences today?
2 things. One is notional and one is technical. The notional thing is that it's taken a long time for production managers to accept that inverters manage stage loadings better than generators. And why do they do that? Because there's no electromechanical lag. There's no fuel pumps required to pull more diesel through
so when the
engine.
base kicks in, you don't see a big plume of diesel anymore. It's just the inverters that can manage it.
We demonstrated a 0 to 1 megawatt load step on this system in Dallas 3 years ago, and it took less than half a second to go from 0 to a megawatt. The other notable thing about that was we actually thought we were doing it across 5 head units, but we only have 4 plugged in. So that was even more remarkable that we did 0 to a megawatt. The frequency didn't blink, basically. But on a generator, as you know, if you stood next to one and there's a big lighting lick or something, you hear the engine go,
exactly.
Catch up
that
with
plume of
themselves.
smoke when the bass drops.
None of that happens. So for years, I've been speaking at conferences and teaching at universities and saying, inverters deal better with spiky stage load profiles than generators. For years, we were like, booed, rotten eggs thrown at us. Now, production managers have now seen the light. The penny has dropped, and they realise that actually these systems are far better suited to stage load profiles. So that's the notional thing. The technical side of the things is the ability to have commercial or industrial 3-phase inverters. For so long, to make 3-phase systems, we paralleled single-phase inverters. Now that works.
They're almost like telecom inverters or different types of inverters that were made for this.
Leisure inverters like Victron. We used Studer in our first systems, which were really nice maritime inverters. But they weren't 3-phase. They were single-phase inverters.
And they weren't designed for this.
They weren't.
None of this was designed for this to start with.
No. So that has made a huge difference. So we now, each one of these contains a 250 kVA 3-phase inverter, but because they're connected in this ring, in this mesh, the actual system is a 1.25 megawatt singular inverter, effectively.
And then kilowatt hours, what's the total capacity of this?
So usable is 1.4 megawatt hours. System capacity technically is 1.66.
Right. So you're getting 80%.
Yeah.
DOD.
We don't go above 90 on the charge. We don't go below 10 on the discharge. So,
how close have you gotten it to completely running out at a show?
probably shouldn't answer that.
You don't need to say who it is.
We've got down to the
Yeah.
to the 30s before.
Yeah.
The interesting thing is though, for instance, with the Coldplay shows, they only use about 400 to 500 kilowatt hours, because all of these peaks and these spikes that scare electricians because they're worried about current and power.
Yeah.
They're so momentary that their impact on the actual energy storage capacity is marginal.
Yeah.
Because a 250k lick for 1 second or half a second is nothing in terms of energy.
Yeah.
But it means a lot to a generator, because it's like, oh my God.
Well, it means that you've got to oversize the generator. You've generators running at 20-30% capacity, and all of a sudden it's now at maxed out peak.
Yeah. And a lot of, I mean, technical people will know this, but a lot of non-technical people will labour under the misapprehension that generators like to be run low load.
Right.
Generators much prefer it if they're running hot.
Yeah.
It's better for the engine, it's better for the longevity of it, it's
Efficiency.
better for the fuel efficiency, less emissions per kilowatt hour produced, that kind of thing. And with tier 5 engines now, they're notoriously unreliable when it comes to actually working under low load, which sort of defeats the object of trying to optimize your generator and getting it to run hard.
How are you seeing hydrogen coming in as a potential? I mean, first it would be a hybrid feature. I know that there's folks that are trying to do hydrogen fuel cells as well for primary generation.
Well, on other projects, I've worked with companies that supply both HFCs, so the fuel cells, but also hydrogen combustion generators, which is a slightly better efficiency, and it's better at dealing with more
like
variable low profile.
Turbine.
But they look, for all intents and purposes, they look like a conventional generator, slightly bigger, but in the same canopy.
The UK's been a leader in this for many decades now. Because I mean, I know I was following a lot of those brands you mentioned, right? The Firefly, Off-Grid Electric, Power to Go. I think that was Off-Grid Electric. There was a dip in the market there. At one point, I felt like the UK was leading, and then there was some sort of a pause in the industry. What was that?
Not everyone within the business agrees with me on this front, but at one point I was head of event power for one of the plant hire companies in the UK, who's now sadly gone bust, and they bought a lot of hybrid systems to integrate into their construction sector. So they spent a lot of money. They needed to get their ROI. So they had their sales teams out, bang, 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 got to get these out. But the sales specialists are not the technical specialists, and therefore a lot of the systems that I saw go out got misdeployed. They were unsuitable for the spec.
You can't run a crane on a small 40 kilowatt system.
No, I mean there are plenty of hybrid systems out there doing tower cranes now, but they were mis-spec'd in terms of perhaps peak power output and the energy storage capacity they needed, maybe overnight for cabins on a construction site with drying rooms on constantly. So in a sense, that mis-speccing gave hybrid systems a bit of a bad name, and it took a while there was a bit of a downplay like that. It took a while for confidence to grow again, and people to actually start deploying them properly.
So it comes down to still communicating clearly, understanding what's capable.
What the requirement is. It's having a brief saying, okay, I've got 7 cabins, 3 of them are going to run for 24 hours a day, 3 of them are going to run for 12 hours a day. Inside those cabins are X, Y, and Z. They're going to pull A, B, and C in terms of power. Once you've got that data, you can then actually work out or estimate what the load profile will be, and then you can specify a 200 kilowatt hour system or a 100 kilowatt hour system. Without that planning and without that understanding, you're going to get nowhere. And as Paul, when you speak to Paul later,
we'll speak to Paul.
He'll say to you, putting a battery out on a show doesn't make a show sustainable. And I'm a firm believer in, and have been for the last 25 years. Clients come to me because they know I've got lots of batteries, and they say, "Can we have some batteries?" And I go, "There's no point. You don't need one on your show. What I'll do is, instead of giving you a 100 kVA biofuel generator, I'll give you a 20, and your fuel efficiency will be optimized in that front." So batteries have to be used with planning.
Right. So, but that means it implies that you need to then measure first. So you need to understand what the actual proper loads are at the various times throughout the production,
100%.
right? And then you've got the planning bit.
Yep.
And then you have to get them on board. You've got to give them comfort.
Yeah.
So that whole process can go on for quite a long time.
What's really important, I think, is you do the planning, you do the deployment, and you take measurements, as you say. You then go back to the client and you say, this data, it doesn't belong to me, it belongs to you.
Yeah.
You're the client.
Yeah.
Look at this. Next time we do this, we could replace X with Y because you've got too much there, or there wasn't quite enough energy storage capacity there, so we need to up your 90 kilowatt hour unit to 120 kilowatt hour.
Yeah.
That gives them the confidence, that arms them with the tools, and that's why they then come back to you, I think.
And then day of, you were bringing me to this computer here,
Yeah.
but also do you have like an energy management layer? Are you guys running around the event grounds with monitoring this on your phones?
I have, so this is the controls page. So we operate each head unit through a web browser. So each of the 5 head units will have a page like this. We then have Grafana, which this is the basic at a glance page, but this shows us all of the energy flows from whatever source we're using to charge and all around the system, and then a cumulative discharge out to the stage. Now, what I would love to show you, but I can't, is our energy logging software. I'll take you to a box.
Sure. Look at these cables.
So, in between the output from the inverter and the stage load is a box connected like this. These are called ADS monitoring boxes.
ABS?
ADS.
ADS.
Yeah. They're just a 400 amp power log through, but inside is a logger.
Okay.
It samples power quality 6 times a second. So I can get instantly, I can see everything that's happening on the stage. So on the Coldplay tour, we distribute power, LX1, which is stage lighting, LX3, which is delays lighting.
Yeah.
I have a box on each of those services. Whenever something happens, whenever the desk operator whacks all the faders up, I see it instantly as it happens.
Are these like Wi-Fi connected, or is there another type of
They are.
communications protocol?
Normally, I would sit here and show you on my laptop,
Right.
but unfortunately, because we're in the US and the line voltage is 277, it's just above the PSU on this, which is 264 as the threshold.
Right.
But what I can do is download all the data,
Yeah.
and then produce a report, which I'm going to do from Open Citizen anyway. But these give me eyes on everything that I can't see going on.
Yeah, exactly. But do you have all this information also kind of on an app, as like on your phone? Because you can't always have the laptop.
I can look at it on my phone or
okay.
on the laptop. Yeah, I generally always have a laptop with me, unfortunately.
Oh, look at these. I mean, this is the real meat behind it, right? This is what people don't see.
This is power. Yeah.
How important are certifications and, like regulatory bodies around certification and stuff? Because I know they can make or break. Some people who sort of like just brought equipment in the field and didn't really think about that, then something happens, and then that sets the industry back. But obviously, it's, especially going from Europe to here, you've got different certification bodies.
Yeah, I mean, the UL thing in the States is massive.
Yeah.
We kind of got involved in that in the early stages of the build of this system. When we produce version 2 of this, I think it probably will go towards UL certification.
Yeah.
In Europe, it's obviously CE, and the other ones there. It's important because A, it gives the venue and the client confidence that it's properly certified. And as you say, B, they won't let you in to certain places if you don't have that kind of certification.
It's still a little bit of the Wild West, but it's going to quickly be a major differentiator between the more amateur folks and the folks that have taken the time to understand.
100%. The thing is, you can't argue your way out of health and safety thing. If a venue says you have to be certified to X, Y, and Z, then you have to be, and it's not something that you can do on the fly. You have to send kit away. They have to try and break it, blow it up, etc. You can't just do that in a day or two.
And also, destructive testing is so expensive, especially if you're in the early stages.
Yeah, it's a big part of your R&D budget, essentially. So, which is something that people don't actually factor in.
This is great. So, and then when you open up the cabinet, is it all exposed there?
No.
Okay, so it's all sealed.
All sealed. Yeah.
Yeah.
Every panel
These
is
are weatherproof boxes.
Yeah, these are completely
Closures.
IP rated. This is very simply, this is the HMI. So if we need to control it off a touch screen because we're not using a laptop, we can do that. This is for startup. So we start up on an external power source. Once we've started up, we switch to busbar power.
That's
and then Spaghetti Junction is over here. So we
you've
talked
got
about
all the European connectors.
So we're connecting from adapting from power lock to US cam lock.
Exactly, the cam lock. Yeah.
We talked about the mesh earlier.
Yeah.
These are the important ones in terms of the mesh. So we daisy chain in and out of each inverter unit, and then the final inverter unit daisy chains all the way back to this one.
Yeah.
That's what allows that bi-directional flow of power. Up here we have our Q21s, which is our outgoing power, 400 amp. And whatever we connect as our charging source comes in through here through Q12, which is also 400
and no problem with the 50 hertz versus 60 hertz. You just can configure them.
Button switchable, button switchable.
Wow.
So here we're operating at 480 volts, 60 hertz.
Yeah.
When I come back for Coldplay next year, I'll be operating at 400 volts, 60 hertz. So
right, and that's on the AC side, and then on the DC side, you said you're running around 800
volt DC,
which makes a lot of sense.
Which is
that's where the EV industry is moving towards, the fast chargers.
Yeah, exactly.
Wow, and then so today in your sound testing, what's been the peak load that you've seen today?
The peak that I've seen today wasn't anything to do with audio. It was television and video.
Yeah.
I saw 199 kilowatts coming out of the head unit that's doing TV and video.
Are you powering anything else other than the stage, or this is purely dedicated to the stage?
We have a little bit of power going through to VIP.
Yeah.
So Cliff is actually assigned to VIP and crew catering, and the other 4 inverters are strictly stage services. So
right. And then where's the site getting the rest of their power from?
I know they've got multiple small optimized generators. I think they've got small battery pads around there. Our brief this year was to focus on the stage services.
Yeah.
Hopefully we'll be back next year and we can talk more widely about maybe just deploying hybrid systems across the site. But one step at a time.
And then how important do you think solar is going to be in at some point with relation to this? Because I mean, obviously we know that you're not going to have a whole solar field in downtown New York City, but at some point, people love solar. They love the idea of solar.
I can give you a really good example. So in April of this year, we did a job for BMW in Rotterdam. It's like a 7-week project. They brought all of their dealers globally to Rotterdam to introduce them to the new electric minis.
Yeah.
So we had 70 electric minis at Greenport in Rotterdam. Now, Greenport in Rotterdam has a beautiful solar array on one of the roofs, about 160 kilowatts. So what we did is we patched into their main supply. So we fed the batteries through the main supply, which was about 180 kilowatts. And then on the output side, we then patched in the solar.
Yeah.
And it got to the point that over the 7 weeks, we actually exported more power back into the Rotterdam grid than we took out of it for charging.
Wow.
So we didn't have a diesel generator in sight. We just had the smart grid system patched into a house supply, a main supply for the port, but also with solar coming in on the output side. And then the fact that we were grid connected meant that when there was excess solar, that could pass back into the grid.
And do you have solar charge controllers in these units, or you had a standalone
That's
unit?
why we favour microinverters basically, and so solar through a microinverter, and then that steps it up to the AC voltage that we want on the output side.
Wonderful, Tim.
Yeah,
thank you very much.
Sorry for rambling on.
No, it's fine. This is it. This is the real meat here. I love it.
Yeah,
Cool.
It's a beast.
Yeah,
It is a
thanks.
beast. Thank you.
Welcome back, everybody. I hope you enjoyed part 2 of our behind the stage interviews with Paul Schurink in part 1 and Tim Benson in this one, part 2, where we go into the behind the scenes of the power system and really look at all the different parts of it and ask all the questions that I love to ask people. And Tim was very, very open and very gracious to let us in. And yeah, hope you really enjoyed it. And make sure to catch part 1 if you didn't catch that one. And we also have our interview with Paul Schurink on our formal podcast, and that should be coming out shortly. All right. Catch you all soon. Thanks.
Hello, entertainment industry. Something I've been working on over the past year with partners U.S. Green Building Council California and Aerith Environmental is the development of the Sustainable Production for Entertainment Certification, or SPEC, as we like to call it.
It's the first certification for the entertainment workforce, and it's now live for folks to sign up.
Yeah, go to the U.S. Green Building Council California website at usgbc-ca.org to learn more about it and to register for an upcoming class. This is a great way to up your sustainability game and gain a professional certification. So this is for you. See you in class. Our designer is Aaliyah Kane. Music is by Peter Chapman. Our producer is Colin Miller.